Right, so let's go through the transfer form from 2011 question. So we have a coherent light incident on the double slit. So we are given the slit separation to be 1.2 mm. The big D, right, the distance from the double slit to the screen is about 2.3 meter. So they tell us that assume that for the fringes near point P on the screen, the light reaching the screen from slit A alone has intensity I, and that from slit B alone has intensity 1/3 I. So means that they have different brightness. So the very first part, we are asked to determine the separation of the bright fringes. This one is simple. You simply just use x equal to d lambda over A. So where x is the fringe separation, so you just do the substitution in. So it's about 1.13 times 10 negative 3 meter. Yeah, so that is the meaning of the fringe separation. Means that, for example, if I draw a few fringes, right? So the fringe separation just means from one bright to the next bright. So this part is the so-called fringe separation. Okay, of course, to use this formula, just ensure that the big D is much bigger than the slit separation. Okay, so that is for the very first part. Okay, the second part, we are asked to determine the intensity in terms of I of a dark fringe near your point P. So dark fringe normally is a zero intensity, but you can see that due to the fact that our light, right, from A and B actually have different intensity, so they do not undergo complete destructive interference, but nevertheless it will still be a destructive interference. Okay, so for the intensity part, just remember that we do not add intensity or minus of intensity, because it's the amplitude that adds or minus of. Okay, so with this, I let the amplitude of light from A, right, from slit A to be x0. So means for example, I is equal to 1k x0 square. So this is from your slit A. So I make k the subject. So k, because k is just a constant, right, k equal to I over x0 square. Okay, with this, right, I want to determine what is the amplitude of the light from slit B. So maybe I just put, okay, for example, I over 3 equal to k x0 prime square, where x0, so for example, right, x0 prime is the amplitude of light from your slit B. Okay, so based on these, you can see that I over 3 go to k x0 prime square, right? So I sub in the k to be as such, because k is a constant, so you can do the substitution in. So with this, I manipulate for a fair while. So I over 3, right, is equal to I over x0 square x0 prime square. So you can see, I cancel the I, then maybe I do the crossover. So it's x0 square over 3 equal to x0 prime square. So you do the square rooting. So this will give you left hand side to be x0 over root 3 equal to x0 prime. So this is the amplitude of the light from slit B. Okay, based on this, it's time to do the so-called subtraction or addition. Because it's a destructive interference, so definitely you must do the subtraction. So this is from slit A, this is from slit B. So you can see that they actually meet in empty phase. So based on this, I simply just calculate what is the amplitude, resultant amplitude of the destructive interference. So you just use 1 x0 minus of 1 over root 3 x0. So this will give you, let me do the calculation. So okay, so it's about, give or take, 0.42264973 x0. So this will be the so-called amplitude of the destructive interference at point P. So with this, you simply just do the calculation again. So the intensity at point P, so let's just say I put I prime is equal to k amplitude square. So this will give you 0.42264973 x0 bracket square. With this, right, of course, not to forget our k, because our k is a constant, I over x0 square. So I over x0 square. So you do the calculation. So this will give you something like this. So our final intensity, right, will be something like 0. Okay, so it's about 0.17863275 x0. So this is 0, Just cancel first. So 0.1786329795 x naught square, of course not to forget our times k times I over x naught square. So you can see, I do the cancellation, right? So definitely my intensity due to the destructive interference in terms of 3SF is 0.179 I. So this will be the answer for the last part.